I have bad news. I will not be talking about directed type theory. Yes, sorry for that. So this is joint work with Benedikt, Paige, who are not here, and Niels, who is in the back. Okay, type theory for comprehension category with applications to subtyping is the title. What is the context? The context is the notational semantics of multi-level type theory. One of the categorical frameworks where you can do this are comprehension categories. And the issue is that this semantics arrow that you can see up there, this doesn't use all the features of the comprehension category, which is this guy here. So there are usually two options that are done. One of them is what you do is you restrict your comprehension categories. In particular, you assume that they are full and split, and then you say that full split comprehension categories are models for multi-level type theory. Something else that you can do is that you can extend your type theory. You start from a comprehension category. Here, you build some internal language from it. You get to this other type theory, which is more expressive than multi-level type theory. Then you compare, you see, yeah, what extra stuff did I get? Okay, so we do this. We call it, what we get, we call CCTT. The CC stands for comprehension categories, if you were wondering. And this is about our work with the preprint is there on arXiv. Okay, cool. Just brief overview of what happened in this work. So as I said, we start from comprehension categories, then we design rules in a way that they reflect the structure of a comprehension category. We show soundness. By that, I mean that we give interpretation in any comprehension category of our rules. And we are extending Corelli and Emenegger's work, that work that they presented, I think, I don't know, 2 years ago at TYPES or something. 2 years ago at TYPES. Thank you, Mevin. So yeah, we give rules that capture coercive subtyping, and then we add pi, sigma, and identity types. We also add subtyping for those, and we also discuss what a suitable semantic structure would be then to have subtyping for pi, sigma, and identity types. Okay, we will see this later. We quickly look at comprehension categories, what they are. Then we look at CCTT. I'll try to quickly convince you that it captures subtyping, and then we extend it with an example with sigma types. Okay, what is a comprehension category? In a comprehension category, we have a base category C, which is a category of context and substitutions. Then you have a cloven fibration P. A fiber over gamma here is a category that has as objects, you can think of it types in context gamma. You have a functor here, which is the comprehension functor, such that this diagram commutes and this comprehension functor preserves Cartesian morphisms. You don't need to worry about this preserving Cartesian morphisms. It doesn't matter for this talk. I'm not going to talk about it. And we say comprehension category is full if this chi is full and faithful. We say that it is split if this fibration P here is split. And full split comprehension categories are models for multi-level type theory, which is what I said in the beginning. And if we look a bit closer into this sentence that I'm saying, what I mean is that you can think of, as I said, this category C here as has an object's context, and the morphisms are your context morphisms. Then if you have a gamma, which is an object in this category, the fiber over it here has as objects types in context gamma. Then substitution is captured by the reindexing functor of your fibration. And if you have a context here, context gamma here, you have a type A here over this gamma. Then this chi takes it to a projection, a morphism from the extended context gamma.A back to the context gamma. And this will come up later that such a judgment, T is a term of type A in context gamma, is then interpreted as sections of these projections from the extended context back to the original context. Okay, so I talked about many things. Now what I didn't talk about is these morphisms in the fibers. What are these then? What do I mean by that? I mean, if you have objects A and B in a fiber over this gamma, you have a morphism from A to BT, which is mapped to this identity morphism. What about this? And these are just the stuff that I told you about at the beginning, that it doesn't use all the features. It doesn't use that semantics arrow doesn't use these morphisms in the fibers. Okay, so this is what is gonna add the expressivity, yes, to the type theory. Okay. Okay, so again, what was the goal? The goal was to design some rules for type theory that reflect all the structures of a not necessarily full comprehension category. And I won't show the rules. I start with the judgments, but I will just not show the rules. Okay, so the first judgment, gamma is a context, then S is a context morphism from gamma to delta, equality of context morphisms, A is a type in context gamma, and then this here, what you see is that this is different from what you usually see, this judgment 5 and 6, and this is exactly, this judgment 5 is exactly the type morphisms that I was showing you in 2 slides before. So this judgment is interpreted as T is a morphism from A to B in fiber over gamma. Okay, so I'm not going to talk about the structure rules. You can see the preprint. Yes, so now we are going to discuss some of the rules through the lens of subtyping in the next section. And this is our Sonnes theorem, just briefly here, that every comprehension category models the rules of CCTT. Okay, so now we are going to put our subtyping glasses on. And what do I mean by that? I mean that whenever we had this judgment like this for the type morphisms, now you're going to think about it as T is a witness for A is a subtype of B in context gamma. And this is due to, as far as I know, Corallia and Emenegger, again with the 2 years ago thing, where they observed that vertical morphisms can be thought of as witnesses for coercive subtyping. Okay, so when we say subtyping, what do we have? We have a subsumption rule. So this is the subsumption rule that we want to get. You can show that it's derivable in CCTT. What does this mean? If T is a witness for A is a subtype of B, and you have a term of type A, you can coerce it to get a term of type B. So you can see here that this gamma dot T is like the coercion function. So it's doing the coercion for you. And it's if you want to know how it's, like, what's the interpretation? This is the comprehension applied to T. Like it's chi of T. Okay, and we also have substitution for subtyping. What do I mean? I mean that if you have what was it? Oh no, how do I go back? I pressed there. Okay. Yes, so if we have that T is a witness for A is a subtype of B, and then you have a context morphism from gamma to delta, then you can substitute in this T, A and B, this S, and you get a subtype relation in gamma, context gamma, and same, just a special case for this. You can also weaken a subtyping to an extended context. Okay, this is pretty standard. Now we're gonna add type formers to CCTT. Okay, how do we do that? We first add the rules for the type formers. For example, here now we're gonna see adding sigma types for an example. And the thing is that here, we don't add rules that have judgments involving the subtyping stuff. Yeah, so it's because all the structure that we need now for the type formers, we're adding it to the category C. So it doesn't include type morphisms. And then after that, we say, okay, so now which sort of type morphisms do we add to make it work with subtyping for, let's say, sigma. Okay, so let's briefly go through this. Let's say we want to add sigma types. What do we do? I've written almost all of them. One of them is missing, one of the rules that we add. I'd say don't worry about it. Okay, so this is the formation rule, pretty standard. You would expect this. Introduction, elimination rule. Still, it's what you would expect to have. You can see the beta here is that if you first do pair, then you get one identity the other way around. And this is this rule tells you that sigma is stable under substitution, and it's just a Beck-Chevalier here. And I haven't written. You have another this Beck-Chevalier for pair or proj, one of them. I haven't written that one. it wouldn't fit. That's why, yes. Okay. And let's say now we want to add subtyping for sigma. What do we do? So what do we expect to have? Because sigma works covariantly on both of its arguments, we expect to have such a rule. Let's quickly go through this. Is if A is a subtype of A prime, and F is a witness for that, and if B in context gamma dot A is a subtype of B prime pulled back along the first subtyping, and G is a subtype for that, is a witness for that, then you should be able to get that sigma AB is a subtype of sigma A prime B prime. And also you expect that the coercion function attached to this witness acts in a certain way. In particular, you want it to act like this. It should first project the pair, then do the coercion on the second argument, then do the first coercion on the first argument, and then it should pair back the things again to get a term of type sigma A prime B prime. This passage in the middle, you can also first coerce on the first argument and then coerce on the second argument. It works. We have there's a commuting diagram here, so it works. Yes. So we add a rule for this, we add a rule for this, and we also add that sigma is functorial. Yeah, I mean, if it's not clear, I mean this sigma here, which gives you the witnesses. It's functorial, and then we say we're done. Okay, so this is on the syntax side, and on the semantic side, we also say we define what we mean by, for example, a comprehension category with subtyping for sigma. Let's say same for pi and identity, and this just mirrors what we had on the previous slide. So let's read it briefly. If it has dependent sums and it is equipped with a function giving for a morphism in fiber over gamma from A to A prime, and each morphism from B to B prime pulled back along this first morphism in the fiber over gamma dot A, you have a morphism like this in the fiber over gamma, such that the comprehension of this guy is this composite that we saw on the previous slide, and that this sigma guy here is functorial. Okay, and then we also have then again a soundness theorem which says any comprehension category with subtyping for sigma types models CCTT extended with subtyping for sigma types. That's what it says. Yeah. So I am mostly done. Just want to tell you about some related work. Maybe you are interested, and also I will. Yes, you'll see. So Sahlberger and Méliès work on. They give a vibrational view of subtyping, so not coercive subtyping. So in their work, also it's funny. I find this funny because they're also vertical morphisms are subtyping in some way, but for them they have this. The base category is a category that has terms as object, and then the thing above it that has the typing derivations as objects. So they're also the vertical morphisms are like they are also typing derivations, let's say, of subtyping, right? So it's different vertical morphisms. Everything's different, but yeah, still I think this is nice. And also, as I said this already. Wait, where is this? Yes. So this I mentioned already. Corellian and Menninger work. Yeah, and then we have also. Laurent, Lennon, Bertrand, and Maillard, which still also 2 years ago at TYPES, yes, so same year. And they have two type theories, one of them for coercive subtyping and one of them for subsumptive subtyping, and they show equivalence between these two type theories that they have. And also, yeah, so Connor already advertised this talk, but I'm gonna also advertise this talk, which is the last talk of today. And as again, related to what I was talking about. And Arthur is gonna talk about it, I believe. Yes. Okay. So yes, that's it, I think. Yeah, this is a summary. That's it.